There is a specific second, not a minute, not a gradual fading. A second, the second your heart stops beating, and in that second something begins that most people spend their entire lives deliberately not thinking about. A precise biological sequence, documented step by step, measured in seconds and minutes and hours. Not mysterious, not unknown, completely mapped by researchers who have spent careers studying the exact mechanics of what the body does. The moment it stops being alive, the sequence is the same for everyone. Every culture, every age, every cause of death. The body follows the same protocol it has followed for every human who has ever lived and died. 200,000 years of the same sequence, running precisely and without exception from the moment everything stops to the moment nothing remains. This is what happens in the first second. The heart stops, not slowly, not gradually. In a single moment, electrical activity ceases. The signal that has been firing continuously since before you were born, approximately 100,000 times per day, for every day of your life stops firing. In that same second, blood pressure drops to zero. Not gradually. Instantly, the brain receives its last delivery of oxygen, whatever that oxygen was carrying, to whatever neurons were firing in the final moment of consciousness, arrives and is used, and is not replaced. Researcher Sam Parnia at New York University has spent years studying the dying process. His research, published in Resuscitation Journal, documented something that changes the timeline. The brain does not lose consciousness. The second the heart stops, it takes longer than that, somewhere between 2 and 20 seconds. For 2 to 20 seconds after cardiac arrest, you are still aware, still processing, still receiving, still experiencing something. What that something is remains one of the most contested questions in neuroscience today. In 2023, researcher Jimo Borjigin at the University of Michigan published research in the Proceedings of the National Academy of Sciences. She monitored the brains of dying patients who were being removed from life support. In the seconds after cardiac arrest, she recorded something nobody expected: a surge of brain activity, not a flat line, a surge gamma wave activity specifically. The same brain waves associated with heightened conscious awareness, with intense focused perception, with the kind of consciousness associated with vivid dreaming, firing at rates higher than normal waking consciousness. In a brain that had just lost its blood supply completely, in a brain that had no oxygen coming in, running harder than it runs during normal life. The body begins consuming itself. Starting with the most fragile cells, brain cells begin dying within 4 minutes. Without oxygen, brain tissue deteriorates rapidly, which is why cardiac arrest, beyond 4 minutes without intervention, produces permanent neurological damage. After 4 minutes, the damage compounds. After 10 minutes without intervention, the brain damage is typically irreversible, but the rest of the body continues much longer than the brain. Heart cells survive for approximately 30 minutes. Kidney cells survive for approximately 1 hour. Liver cells survive for approximately 2 hours. Skin cells survive for approximately 24 hours. Corneal cells survive for approximately 36 hours. Bone cells survive for approximately 36 hours. The body does not die all at once. It dies in sequence. Different tissues on different timelines, different cells surrendering at different rates, which is why organ donation is possible, which is why corneal transplants work hours later, which is why the body we call dead still contains living components for hours and sometimes days after the heart has stopped permanently. Death is not a moment. To understand why the body follows this specific sequence at death, you have to understand what the body actually is. Not a self, not a person. At the biological level, the body is a collection of approximately 37 trillion cells, each one a living organism in its own right, each one running its own metabolic processes, each one with its own survival drives. When the heart stops, the cells do not receive a signal saying stop. There is no signal. There is only the absence of oxygen. And each cell responds to that absence, the same way any living organism responds to a threat to its survival. It fights. It consumes available resources. It attempts to maintain function. It does not know the heart has stopped. It does not know the organism is dying. It only knows that the oxygen is gone, and that its job is to continue anyway. Your body at the moment of death is not dying all at once. It is 37 trillion organisms, each discovering the crisis individually and each fighting it alone. Within hours of death, a different process begins. The bacteria that live inside your body and have lived there your entire life begin moving outward. During life, your immune system maintained boundaries, kept the bacteria in their designated regions. Gut bacteria in the gut, skin bacteria on the skin, each population in its territory. When the immune system stops functioning, the boundaries dissolve. The bacteria move freely through tissue, through organ walls, through everything that was previously controlled. And they begin consuming the body from the inside. Not as invaders, as the organisms they have always been doing what they have always done, processing organic material, breaking it down, converting it into something else. Researcher Gulnaz Javan at Alabama State University has spent years studying what she calls the thanatome microbiome, the microbiome of death, the bacterial community that takes over.